Have you ever asked an AI to write a poem, draft an email, or even plan your vacation? It's becoming increasingly common to turn to these digital assistants for help with everyday tasks. It feels like magic, right? Like having a super smart assistant at your beck and call, ready to answer any question or fulfill any request. The responses are often instantaneous and incredibly helpful. But here's the catch. A single AI chat can use up to 10 times more electricity than a Google search. That's a significant difference, and it's something most people aren't aware of. Multiply that by millions of users, each engaging in multiple AI chats per day, and the energy demand is staggering. It's a hidden cost that's quietly adding strain to our power grids. We rarely think about the power behind our digital habits, the electricity that fuels every click, scroll, and conversation. It's invisible, tucked away in massive data centers, humming with activity around the clock. Yet every AI conversation draws real electricity, powering the servers and cooling systems that keep these digital brains functioning, with real environmental impact. This energy consumption contributes to carbon emissions and other forms of pollution. Imagine billions of people chatting with AI daily, asking questions, seeking advice, and generating content. The power needed is enormous. A demand that could potentially overwhelm existing infrastructure, like lighting up entire cities just for our curiosity, fueling our endless quest for information and entertainment. AI isn't bad. It offers incredible potential for innovation and progress, but its growing appetite for energy is a challenge we can't ignore. We need to find ways to make AI more sustainable. A regular search is like finding a book in a library, a quick and efficient process. An AI chat is like asking a team to read and summarize hundreds of books just for you, synthesizing information from countless sources. That complexity means more powerful chips requiring more energy to operate, more heat, and much more electricity. The servers need to be constantly cooled to prevent overheating. The convenience we enjoy comes with a hidden cost, a significant environmental footprint that we often overlook. Next time you chat with AI, remember, be mindful of your usage and consider the energy implications. It's not just code, it's powered by a lot of energy, drawn from power grids that may rely on fossil fuels. Realizing this is the first step towards smarter, greener solutions, and a more sustainable future for AI. The world's top minds are racing to make AI more efficient, developing new algorithms and hardware that consume less power. The journey to sustainable AI is underway, a shift towards renewable energy sources and energy-efficient designs. And it's one of the most exciting challenges in tech today, pushing the boundaries of innovation and sustainability. The future of AI depends on how we choose to power it, and whether we can prioritize sustainability alongside innovation. Consider that. Why does AI use so much electricity? It's all about complexity. When you ask an AI a question, it's not just searching a database, it's generating a brand new answer from scratch. This means activating huge networks of artificial neurons, weighing billions of parameters, and running on specialized chips called GPUs. These chips are powerful but energy-hungry, generating lots of heat. Training an AI is even more intense, feeding it massive amounts of data for weeks or months using as much electricity as hundreds of homes. As we demand smarter AI, the models get bigger and need even more power. It's a cycle: bigger models, more data, more energy. The challenge isn't just the size of the models, but the hardware and energy needed to run them. Building more data centers isn't enough, we need a smarter, greener approach. The future of AI depends on it. All this power use has a real-world cost, far beyond the electric bill. Data centers, the backbone of AI, already consume up to 2% of global electricity, and that number is rising fast. If these centers run on fossil fuels, every AI chat adds to greenhouse gas emissions. The environmental impact is direct: more digital activity, more carbon in the air. Data centers also use massive amounts of water for cooling, sometimes millions of gallons a day. In a world facing water shortages, that's a growing concern. Building and running these centers costs billions, with electricity as the biggest expense. These costs trickle down to companies and, eventually, to us. Inefficient tech isn't just bad for the planet, it's expensive. The pressure is on to innovate. Making AI more energy efficient is both an environmental and financial necessity. The stakes couldn't be higher. Imagine a landscape transformed, a field of solar panels stretching as far as the eye can see, meeting the horizon in a shimmering expanse of dark blue. And what are they powering? Not just a home, not just a factory, but a massive data center, the very heart of the digital world. This is more than just a concept, it's the burgeoning reality of sustainable computing, artificial intelligence fueled directly by the sun's boundless energy. Inside these facilities, every single detail, from the architecture to the software, is meticulously designed for peak efficiency. Smart cooling systems intelligently draw in outside air, taking advantage of natural resources to regulate temperature. Some even employ advanced liquid cooling, circulating specialized fluids directly to the processors, keeping servers cool with dramatically less energy than traditional methods. Servers are packed tightly together, maximizing space, and airflow is carefully optimized to prevent hotspots and ensure even distribution of cool air. And pushing the boundaries even further, some pioneering centers are experimenting with advanced liquid immersion cooling, submerging entire servers in specialized fluids to cut energy use to unprecedented levels. When the sun shines brightly, generating more power than the data center needs, that excess energy isn't wasted, it's stored in giant batteries, ready for use when needed. At night, or during those inevitable cloudy days when solar production dips, the data center seamlessly draws power from these batteries, ensuring uninterrupted operation. This allows the facility to operate with a commitment to green energy, around the clock, every day of the year. If absolutely needed, the electrical grid stands ready as a backup. But the overarching goal is to minimize reliance on it, striving to run on clean, renewable energy as much as humanly possible. Every single watt saved on cooling through innovative design and technology is a watt that can be redirected to power computation, fueling AI and other demanding applications, or even better, saved entirely, reducing the overall energy footprint. It's a carefully crafted, self-contained ecosystem, meticulously designed to support a digital world without placing an unsustainable burden on the Earth's precious resources. These solar-powered data centers stand as powerful proof that we can indeed have both: the immense power of artificial intelligence and a steadfast commitment to protecting our planet for future generations. The real challenge now lies in scaling this groundbreaking model, replicating its success and implementing it in data centers across the globe. The race is officially on, a global effort to transform every data center, making them as environmentally responsible and as green as the leading examples we see today. The future of AI is undeniably solar, undeniably smart, and undeniably sustainable. This isn't just a trend, it's the new standard, the benchmark against which all future data centers will be measured. Let's embark on a fascinating comparison, a true power showdown. AI supercomputers, marvels of modern engineering, pitted against the original supercomputer, the human brain. We're talking about raw processing power versus unparalleled energy efficiency. The brain effortlessly juggles everything from composing intricate music to solving complex problems, handling creativity and logic with equal ease. And it accomplishes all of this on a mere 20 watts. Less power than it takes to keep a dim light bulb glowing softly. It's an incredible feat of biological engineering. AI, by contrast, demands hundreds, even thousands of times more energy to perform similar tasks. The energy consumption is staggering. Training a single major AI model can consume as much electricity as powering an entire small town for a significant period. The environmental impact is a growing concern. So, what's the brain's secret to this remarkable efficiency? The brain processes and stores information in the very same location, eliminating unnecessary data transfer. It utilizes parallel electrical and chemical signals, working in harmony. There's no constant shuffling of data back and forth like conventional computers. It's just pure, unadulterated efficiency in action. Billions of years of relentless evolution have sculpted the brain into the ultimate low-power, high-performance machine we know today. This incredible efficiency is now inspiring scientists and engineers to design computer chips that mimic the brain's architecture and functionality. If we could successfully replicate even a small fraction of the brain's energy efficiency in our technology, it would spark a revolution across the entire technological landscape, transforming how we compute and interact with the world. Data centers would consume significantly less power, operational costs would plummet, and the benefits of AI would become accessible to everyone, everywhere. In the quest for sustainable computing, the human brain stands as the undisputed gold standard, a beacon of inspiration. The future trajectory of AI development is increasingly guided by nature's most elegant and efficient designs, a concept known as biomimicry. That's the next quantum leap in computing, a future powered by brain-inspired innovation. The answer to AI's power problem? Green computing. It means designing, building, and using computers in ways that minimize environmental impact. The goal: cut energy use and power everything with renewables. It's a holistic approach: efficient data centers, smarter chips, and software that does more with less. Even simple steps like sleep mode add up globally. The most exciting frontier? Rethinking computers from the ground up. Scientists are exploring radical new architectures inspired by the brain to achieve massive energy savings. Green computing is about seeing energy as precious and using it wisely. It's a mindset shift, technology and sustainability working together. The future of AI depends on making every byte count. That's the promise of green computing. To truly solve AI's energy problem, we need bold new tech, like quantum computers and neuromorphic chips. Quantum computers use qubits, which can be 0, 1, or both at once, exploring countless possibilities simultaneously. This could make them ultra-efficient for complex tasks, like training AI or simulating new materials. We're still in the early days, but the potential is huge. Neuromorphic chips are another breakthrough. They mimic the brain's structure, combining memory and processing. They only use power when active, just like neurons. This makes them thousands of times more efficient for tasks like speech or image recognition. Imagine powerful AI running on your phone, not just in giant data centers. These brain-inspired chips could bring green AI everywhere. The future is quantum, brain-like, and energy-smart. That's the next revolution in computing. And it's coming fast. The world's biggest tech companies are racing to go green. Google, Microsoft, and Amazon are investing billions in efficient, renewable-powered data centers. Google aims for 24/7 carbon-free energy by 2030. Every search, email, and video powered by clean electricity. They build their own wind and solar farms and use AI to optimize energy use. Microsoft's Project Natick submerged a data center in the ocean, using cold water for natural cooling. These companies are also investing in carbon capture and setting ambitious climate goals. Their scale means real impact. When tech giants go green, the whole industry follows. Hardware makers design better chips, energy providers build more renewables, and standards rise. The race for powerful AI is now also a race for the greenest AI. It's a competition where everyone and the planet wins. The green revolution is real, and it's happening now. What does this mean for you? A greener digital future is on the way. Soon, every AI chat, search, and stream will be cleaner and more efficient. The invisible energy cost of your digital life is being tackled by science and innovation. Imagine AI on your phone running for days, or quantum-powered research finding cures faster with less environmental impact. Green computing will make tech more powerful, accessible, and sustainable. Efficiency is the new mantra: smarter algorithms, ocean-cooled data centers, and lower costs. The most successful tech will be the most energy efficient. Green computing is both an ethical and economic imperative. Every digital action you take will be part of a cleaner ecosystem. The future is bright, and thanks to green computing, it's getting greener every day.